Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at how to use the sine rule. Now, use the sine rule to find unknown sides or angles in non-right angled triangles. If a triangle is right angled, we can just use SOHCAHTOA. But we're going to look at non-right angled triangles. So it's important to note that we label the sides differently in these non-right angled triangles. Instead of using opposite, adjacent, hypotenuse, we call the sides A, B, and C. It doesn't matter which way around you label the sides, as long as angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. So we usually use capital letters for angles and lowercase letters for sides. So with that in mind, the sine rule is that A over sine A equals B over sine B. Use this formula if you're finding an unknown side, and you can just flip each of these fractions if you're finding an unknown angle. So let's look at this question here. This is clearly a non-right angled triangle. We can't use SOHCAHTOA to find x. We're going to use the sine rule. So the sine rule says that A over sine A, so this will be like my little a, lowercase a, that means this is angle A. So when we're using the sine rule, it's really important we get a side over its opposite angle. So it has to be sine 20 on the bottom. And then similarly, B will be 20 and sine of B will be 130. So this is a side angle pair because they're opposite. This is a side angle pair because they're opposite. So this equation is very easy to solve once you get to this step. Sine 20 is just a number. It's not a nice number, but it's a number nonetheless. You know that when you want to undo dividing by a number, you simply multiply each side of the equation by that number. So in the calculator, we're just going to put 20 sine of 20 divided by sine of 130. So making sure your calculator's in degrees, we get about 8.93. So we should always check the answer. There's no way we could have known at the start that our answer would be about 8.93. But because this side is opposite a smaller angle than this side, it must be a shorter side. This side had to be less than 20. Because we did get an answer less than 20, we know we've done something right. All right, let's now look at using the sine rule to find unknown angles. So when we're using the sine rule to find an angle, we need to already know two sides and another angle. Really, you need a side angle pair and another side. Now, finding angles using the sine rule is a little bit more complicated because sometimes there's an ambiguous case. Sometimes there are two possible values for the angle you're trying to find. Now, I'll explain when that occurs through these two examples, but let's look at the first example here. I want to find theta. Now, when you're finding angles using the sine rule, angles on top. Sine theta over 10 equals sine 50 over 11. Remember that we have to have angles with their paired side. This is a side angle pair, this is a side angle pair. So to solve this equation, what I would do was multiply each side by 10. So I'd get 10 sine 50 over 11. That's equal to sine theta. The way I undo taking the sine is sine inverse. So I can get rid of that sine if I take the sine inverse. Remember, that's the sine with the little -1. So I just put it straight on my calculator like this. I get approximately 44 degrees. And that sounds about right. This was opposite a shorter side, so it had to be less than 50 degrees. Turns out there's no ambiguous case in this triangle, but there is in this triangle. So let's look more closely at this triangle. The way I'd find theta is the same. I'd still have sine theta over its opposite side equals sine 50 over 10. So again, I'd want to multiply each side by 13 and take the sine inverse. So here I'd get sine inverse of 13 sine 50 over 10 and put that on our calculator. So putting that on the calculator, we get about 85 degrees, but it turns out there's another possibility for theta. So why were there two possible values for theta here but not here? It's simply because here the angle we wanted to find was opposite the shorter of the given sides. 10 is shorter than 11, whereas here the angle is opposite the longer of the given sides. 13 is longer than 10. So whenever the angle you're trying to find is opposite the longer given side, there are two possibilities. One of them you compute in the usual way. The other possibility, the ambiguous case, you just take your answer and subtract from 180. So in this diagram, theta could be 85 or 95. We need to give both possible solutions. Now what's going on here, you can see that one of the answers was acute and one was obtuse. It is possible that a triangle with these dimensions has a largest angle that is either acute or obtuse. We don't know which one. But here, this angle could not be obtuse. The reason is it was opposite a shorter side. In any triangle, the largest angle is always opposite the longest side. If I were to subtract this from 180, I would get 136 degrees. Well, we can't have this angle being 136 because then the angles in the triangle would add to more than 180. That's why this one has no ambiguous case. So if you're finding it confusing to note when there is or isn't an ambiguous case, whenever you get an angle answer using the sine rule, subtract your answer from 180 and see if that's possible. See if it would make the angles add to more than 180, or like in this case, it wouldn't. The ambiguous solution is possible here because it doesn't make the angle sum exceed 180. The ambiguous solution was not possible here because then the angles would add to more than 180. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.